What's up, everybody? Today we're going to be taking a look at linear and nonlinear systems of equations. So, there's going to be three types of solutions that we're going to be looking at when we're talking about quadratic linear systems. Let's represent them graphically. So this first one says two solutions. So that one is pretty much our most basic one. We're going to have a quadratic. All right, doesn't need to be pretty. Just throw a quadratic on that graph. And then we would have a line going through that quadratic just diagonally somehow. And notice we would get two solutions, right? We would get a solution here where it crosses, and we get a solution right there where it crosses. Okay, how can we get one solution? So if we draw another quadratic on here, one possible way to get a singular solution is to have a vertical line passing through this graph. A vertical line would give us one solution right where it crosses on that vertical plane, or in that vertical spot. Another possible way to get a singular solution is this, where it just skims the graph, okay? This is actually called being tangent to the graph, which is something that you'll learn. I don't know if you learn it in pre-calc, but definitely we'll talk a lot about it in calculus. Okay, so there's two possibilities for getting one solution for a linear quadratic system of equations. And then how we could get no solution? Well, this one is if our quadratic is opening in a specific direction, and then our linear graph is just somewhere beneath it, right? It's never going to cross it. It's just beneath the quadratic graph. So the next question says, could there be a quadratic linear system with infinitely many solutions? And this is a big no. The reason this is no is because a linear system is linear, right? For it to have infinitely many solutions, we would have to somehow be overlapping the quadratic, right? And with a linear system, we're never going to be able to overlap this quadratic. We might be able to get close to being the same steepness at some point, like this, but that's still only going to cross it either twice or maybe just one time hitting it tangentially. But either way, there's not possible to get an infinitely many solutions. Just like in our last couple sections, there's graphing that we can solve these questions by, so let's do that first. So I'm going to graph this first equation in green here. So it's -2, and then it says the slope is 1, so up 1 to the right one, up 1 to the right one, and if we graph that, it should look like this, hopefully. Boom, there it goes, sticks. Down like that. Okay, and then our next graph, I'll graph in this like purple color. It says x squared minus 4x minus 2. It says, hint, use x equals -b over 2a to find the vertex. So let's do that. -4 over 2 times 1. So that's going to be 4 over 2, which is just 2. And then we got to plug that in because that's the x value of the vertex. So we'd go y is equal to 2 squared minus 4 times 2 minus 2. So y equals 4 minus 8 minus 2. So 4 minus 8 is -4, so y equals -6. So we're going 2, -6, 1, 2, 3, 4, 5, 6 puts us here. We know it intersects the y-axis at -2, so -2 puts us right here. We can draw a point, so that's 2 away from the axis of symmetry. So we can draw that next point over here. All right, and then it's not bad to find another point here so that we get 5. So if we're going right 1, I'm going to go right 3, which 3 squared is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then draw on the other side. So then now we have this quadratic graph that we can see clearly crosses in two spots. All right, what are those 2 points? So one of them is at 0 for an x, -2 for a y. The other one is at +5, comma, 1, 2, 3, +3. So 0, -2, and 5, comma 3 would be the solutions for that graph. All right, I'm going to have you guys try number 2 on your own here. So let's go down to method number 2, substitution. It says use substitution to solve the following system. All right, so substituting. They're both already set equal to y, so we could plug one into the other, or we could plug in either way. It's going to be the same exact thing no matter what you plug in. You're just setting one equal to the other, basically. So we're saying 2x minus 2 is equal to x squared minus x minus 6. All right, if we're going to solve for this, we need to set this quadratic equal to 0. So I'm going to subtract 2x, add 2. Subtract 2x and add 2 would be 0 equals x squared minus 3x minus 4. Hopefully this factors. If it doesn't, we'd have to use quadratic formula. So let's see. We got x and x, negative 4 going in one, positive 1 going in the other. Looks good. So this is going to be x equals negative 1. Didn't mean to put that equal sign. And x equals positive 4. This is not done yet, though. Okay, this is a system of equations. This is only half of the answer. So we need to next figure out, well, what are the y values for these? So what I would do is I would just plug these both into the first equation, because I would say it's much easier to plug in answers into a linear equation than a quadratic equation. So we're going y is equal to 2 times negative 1 minus 2. So that's y is equal to negative 2 minus 2, so y is equal to 4. And then in the other case, we have y is equal to 2 times 4 minus 2, so y is equal to 8 minus 2, so y is equal to 6. So then our two solutions for this, they are real, okay, because we actually found numbers instead of imaginary numbers through the quadratic formula. And then the solutions would be negative 1 comma 4 and 4 comma 6. All right, so those would be our solutions. All right. The next one says use substitution to solve the following system. Again, now that I've shown you an example, I would love for you to try that one on your own. Should work out nicely to factor. Okay, so make sure it factors. That's how you know you're on the right path. It says this next one is fun. Think quadratic formula. All right, so if you don't remember the quadratic formula is x equals the opposite of b plus or minus square root of b squared minus 4 times a times c, all of it divided by 2 times a. So if you needed that quadratic formula, there it is, okay? And again, this is still a substitution question, so you're going to set x minus 3 equal to x squared minus 2x plus 1, but I want you guys to practice using that quadratic formula, so I'm going to have you guys do number 5 as well. Okay, the next thing that we're going to look at is that we could have a system with linear equations and an absolute value equation. So this says solve by graphing. You may use your graphing calculator, but I don't think we need one. Let's try to do this just by hand. So this is saying 14 thirds is where this is crossing at. So 14 thirds would be, 15 thirds would be 5. So 14 thirds would be 1/3 less than 5. So we're right here. And it's telling us to go up 2 to the right 3. So we're going to go up 2, 1, 2, to the right 3, 1, 2, 3. And then I'm going to go down 2, so 1, 2, to the left 3, 1, 2, 3 puts us right here. Okay, so there's our graph. Hopefully this lines up nicely. Okay, so we had to be super particular when graphing that one, so make sure that you are also very particular when you're graphing that one. The next is graph of the absolute value function here. So we have positive 6 inside, we have a 2x. So we've never actually talked about how to graph something like this. So what you have to do though, and that's because this has a horizontal stretch, which we've only talked about vertical stretches. You're going to pull that 2 out of there. So you're going to go y is equal to 2x plus 3. We factor the 2 out of both of those things. Okay? That tells us right here that this graph is getting shifted to the left 3. So we go left 3, 1, 2, 3. Puts us right here. And then, quite honestly, the easiest thing to do after this would to be plug in numbers and get out values, okay? So let's just do that, x and y. Okay, so if we just are plugging in some numbers, if we plugged in, let's just go negative 2, because we're right there. So if we went -2, -2 plus 3 would give us +1. 1 times 2 is 2. So at -2, we're at +2. And because this is absolute value, that's going to tell us that it's also just doing the same thing on the left. So notice this value right here is actually just the slope. Okay, so then we can draw these up. Hopefully we cross at good spots. Looks like we do, actually, so that's nice. So then we have a point here and a point right here. So that's going to be -4, +2. So -4, +2. And then our other is -1, +4. So -1, +4 would be the other solution. And again, they're both real solutions because we actually found answers. Okay? So this last part says, now that you know the solution, how could we solve the same system by using substitution? Hint, you need to set up two different equations to solve an absolute value equation. So we're going to set them equal to each other because we're just going to substitute y in for the other y. So we're going to go 2/3 x plus 14/3 is equal to 2x plus 6 absolute value. All right, and then here is the trickier part, right? So here is where this thing right here can be positive or negative because the absolute value is going to make it positive no matter what. So then here's where we're going to set up our two different scenarios. One of the scenarios is going to be our positive scenario, and then I'm going to actually make this a different color. So we'll have a negative scenario, and we'll have a positive scenario. So positive is going to be 2/3 x plus 14/3 is equal to 2x plus 6. Nothing changes. For the negative scenario, we're going to have 2/3 x plus 14/3 is equal to -2x plus 6. All right, so there's our positive and our negative for our absolute value again. So I'm going to solve the positive first. Thinking of solving this fairly easily, I am going to multiply by 3 to get rid of the fractions because that just sounds convenient to me right now. So if we do that, it would be 2x plus 14 is equal to 6x plus 18. Then I'm going to subtract 2x from both sides, subtract 18 from both sides. That's going to give you -4 equals 4x. Divide by 4 on both sides, and you get x is equal to -1. On the other side here, I'm going to do the same thing. I'm going to multiply everything by 3. That's going to give us 2x plus 14 is equal to -3, 2x plus 6. Now I'm going to distribute that -3 in, so 2x plus 14 is equal to -6x minus 18. Now I'm going to add the 6x to this side, and I'm going to subtract 14 to the other side. So that's going to give me 8x is equal to -32. Divide by 8 on both sides. X is equal to -4. So we've already done a lot of work for this question, but we can't stop here. Remember, the solutions to a system of linear equations is an x value and a y value. So then we come back to it, and we are going to plug each of these into the first equation. So I'm going to plug -1 in for x. Actually, you know what? I'm going to plug it into the absolute value. It sounds like it's a little bit easier. So plug in -1 here. So that's going to be y is equal to the absolute value of 2 times -1 plus 6, which y is equal to absolute value of -2 plus 6. So y is equal to absolute value of 4. So that's y is equal to 4. So then our first point is -1, comma 4. Awesome. The next point we would plug in, so I'm going to plug in -4 into the absolute value equation now. So that gives us y is equal to the absolute value of 2 times -4 plus 6. So y equals the absolute value of -8 plus 6. So y equals -2 in the absolute value. So y is equal to 2. So then this answer is going to be -4, comma positive 2. All right, and then those would be our two solutions to the system. Okay, so you have a couple problems you need to finish yet still. We got 5, 4, and 2, so just 3. As always, though, if you have questions or are struggling, please feel free to ask me. That's what I'm here for, guys. Hope you guys have a great day. See you later.